Dear ladies and gentlemen, my name is Erisa. I'm a mathematician. So I want to teach you mathematics online. I know most of you at home. So we are trying all possible ways to reach you out so you don't miss out so much on what you're supposed to be studying in school. So I'll be teaching you basically mathematics, pure mathematics, applied mathematics, maybe numerical methods. Okay. So today we are starting with something very simple, something which everybody can just work out in one day and get everything, and that's differential equations. So what is a differential equation? A differential equation is a relationship between an independent variable x, a dependent variable y, and one or more differential coefficients of y with respect to x. Let's look at some examples. Okay, we have x, dy by dx plus y sine of x equal to 0. That's a differential equation. Okay, x is the independent variable, y is the dependent variable, dy dx is the differential coefficient. So how are they related in this equation? We can say a product of x and the differential coefficient plus y times sine of x is equal to 0. This is the relationship. So this is what we're going to study. Okay, another example could be xy dy by dx plus y dy d2y by dx squared d plus e to power x equals to 0. That's also a differential equation. Here we have the first derived function and the second derived function. Okay, remember we said that it's the relation between x, y, and dy dx, one or more differential coefficients of y with respect to x. So next we get to understand what we mean by order of a differential equation. Before we go deeper into understanding what a differential equation is, one of the things we have to get familiar with is the order of a differential equation, because the order matters when we're trying to find the solution of a differential equation. Okay, so we start. The order of a differential equation is given by the highest derivative involved in the equation. Let's take an example. So let's look at this equation. It's x squared dy by dx plus y sine x is equal to 0. Now, when you look at the derivative which is appearing in the equation, the highest power of that derivative, or the highest derivative, is dy dx, and therefore it is first order because the highest derivative here we have here is just dy dx. It's not second derivative, it's just first derivative. Okay, so this becomes a first order differential equation. Now let's look at the second equation, which is xy d2y by dx squared minus y sine x is equal to 0. Here you see the highest derivative appearing in this equation is the 2y by dx squared. So this equation is second order differential equation because the highest derivative appearing is a second derivative. Okay, let me hope this point of order of a differential equation is understood. It is determined by the highest derivative appearing in the equation. So you can always tell the order of a differential equation by looking at the equation and trying to identify the highest derivative which appears in that equation. So the first one here is first order. Then this equation 2 is a second order differential equation because the highest derivative appearing in this equation is the 2y by dx squared. Okay, let's try to emphasize this more by looking at another differential equation which might confuse a student. I'm telling you, this is just easy. We are just getting to familiarize ourselves with the term that we shall be using differential equations. Now let's look at this equation 3. It is x times the first derivative is cubed minus y times the 2y by dx squared, then plus y sine x is equal to 0. Yeah, a student might be confused about this equation. One might be tempted to think that this is a third order differential equation because you are saying dy dx has been cubed. But that's not true, okay? We look at the highest derivative. Here we have two derivatives. We have the first, which is dy dx, and then the 2y by dx squared. So this equation is a second order differential equation because the highest derivative appearing is a d2y by dx squared. Let me hope this point of order of a differential equation is well understood. Okay, so we are talking about differential equations. We have got to understand what we mean by order of a differential equation. But how are these equations formed? Okay, so differential equations may be formed in practice from a consideration of the physical problems to which they refer. Mathematically, they can occur when arbitrary constants are eliminated from a given function. Okay, so let us look at this equation. We have been given y equals to a sine x plus b cos x. So here a and b are arbitrary constants. Now the task we have is to eliminate a and b, to do with a and b so that we have an equation where a and b do not appear. Okay, that equation will involve a differential coefficient. So let's get started and get to understand this. So here, if we happen to differentiate, we get y by dx equals to a cosine of x minus b sine of x. The reason is when we differentiate sine, we get cosine. But when we differentiate cosine, we get negative sine. So the first derived function is dy dx is equal to a cos x minus b sine x. Okay. So we had dy dx is equal to a cos x minus b sin x. You remember our intention to eliminate a and b. So how do we do with a and b so that we have an equation which is purely defined in terms of x, y, and maybe dy dx? Okay, so here we don't have a y, but at least we are going to have dy dx. So let's differentiate again. When you differentiate again, you will end up with the second derivative as being equal to minus a sine of x, okay, minus b cosine of x. Why something like this? It's because when I differentiate a cosine, I get negative sine. And when I differentiate a sine, I get a positive cosine. But there's negative sign before, so we end up with this equation. But if we are to realize this, let's look at this equation, okay? This can be written as, you can pull out a minus, and we have a sine of x plus b cosine of x. So let's look at this critically, and what we are given. Remember, we are given y is equal to a sine x plus b cos x. So when you look at this, you realize that this is a minus 1. Is it true? Yes. So our dy dx, our second derivative, okay, it has given us a minus 1. Check this equation. We have been able to do away with the arbitrary constants a and b, and we are having dy dx equals to the 2y by dx squared is equal to minus y. Okay, so we can start here. Therefore, our d2y by dx squared plus y is equal to 0. Okay, and this is the differential equation formed. Okay, it is a second order differential equation when we look at it. So we have been able to eliminate a and b, and in the end we are having a second differential coefficient plus y is equal to 0 as the equation which we have formed. So it is really easy, okay? Let's look at another example so we get to know how we form these differential equations. Actually, when you are dealing with differentiation, there is somewhere where you are forming these equations, okay? Without realizing that we are forming differential equations. At the end of this, I will give you some good exercise that will take you through this so you can form as many as possible, okay? Let's look at an example, a second example about formation of differential equations. Suppose we are given y equals to x plus a over x, okay? And we are told to form a differential equation. You know, the task we have is to eliminate a from this equation, okay? Now, the best way is to first write this equation in a simple way that will enable us to differentiate easily. So this is plus a x to power minus 1. We all know that 1 over x the same thing as x to power minus 1. So if I have a over x, that is ax to power minus 1. Next, we apply derivatives on both sides. This step is important because you are trying to show, suppose you're in an examination, you are trying to show that you are going to differentiate, okay? Or you can write differentiating both sides so that the person who's trying to follow up what you are doing really understands what's going on. So when you differentiate this equation, you end up with 1 minus a x to power minus 2. Now remember the task we have is to do away with the arbitrary constant a. So we can first write this. We can write this as dy by dx equals to 1 minus a over x squared. Just simple mathematics. Okay. So since our task is to take away that a so that we have an equation where a does not appear, in this case, just very easy. So why don't we go ahead and multiply everywhere by x squared? So we have x squared dy by dx equals to x squared minus a. Okay, so that means that if I want to make a the subject, then it is going to be x squared minus x squared dy by dx. Okay, now we want to substitute for a so that we have an equation which does not involve a. So here it is just easy. We're almost done. So let's go ahead and substitute for a in the equation. Let's substitute for a in this equation. Okay, we are going to have y equals to x plus x squared d minus x squared d dy by dx. This is divided by x. Now it is really simple, okay? So next you'll end up with y is equal to x plus x minus x dy dx, and when you manipulate this further, you'll end up with the x dy dx equals to 2x minus y. And now this is the differential equation we have formed. We have been able to do away with the a, and in the end we have a relationship between x dy dx and then a y. So when you get that relationship, then you have formed a differential equation. Okay, so all right, you can try to form a differential equation from this. That's y equals to ax squared plus bx. Okay, yeah, you try it out and see if you can eliminate a and b, and you end up with a relationship where you have x, y, and then the differential coefficients. It is quite easy. You can actually do this as you enjoy a cup of black tea. All right.